We're finished with the watery talks, and just to finish off the whole day and the day and a half of the conference, Martin Smith's going to step back and really look at the CUSP project from a broader dimension, a global dimension even. So Martin, it's over to you.
Okay, thank you. Congratulations, ladies and gentlemen, you've made it to the final talk. And I had a set of notes which were going to be, the outline of what I was going to say, but over the last day and a half, of course, I've been scribbling all over them, and it's incredibly difficult, as you might imagine, to synthesize the wealth of data and information that you've been provided with. But when Diarmad said to me, as somebody who was involved and very passionate and interested in the setting up this project originally back in 2000, if I would like to give a summary of what's been achieved in the CUSP project, of course I foolishly said yes. And I just reflect back a bit to that step diagram that Diarmad's used and Hans de Beer used. That diagram, a lot of the issues I'm going to talk about are about making those first initial steps. They're often the most difficult ones, and that's partly what I was involved in the early days of setting up a multidisciplinary project in BGS in Glasgow. Glasgow was an obvious target. It was doable. It had already had a good relationship with the city partners. It had a lot of data we could start doing a lot of things with. So it's very gratifying for me to now see that where this has all gone 10 years down the road. And finally, I'd just like to express my own personal thanks to all the BGS staff and their numerous researchers who have worked on this project over the years. Laterally, I've not been involved in it, but all of it has only happened because we have very good relationships and strong partnerships with the academic researchers and, importantly, the Glasgow City Council. So what I'm going to try and do is look beyond what's been achieved in Glasgow and to consider what the impact might be of CUSP on the global urban community. So in the next 10 minutes, and I beg your indulgence if I slip over the mark, but you will tell me, Breeze, when I've got 5 minutes left, please. I will set a little bit of context, talking about the growth of cities in crisis and the urban footprint, why the subsurface importance, a lot of what you've heard already today. But I'll then move on to a summary of what it is that CUSP is offering to the world, and use one example that BGS is starting to become more involved in, and that is Singapore. I've got one slide on next steps, what that might look like, and then a quick summary. The three take-home messages I think that I picked up from today, without going into the details, of course, are about the importance of partnership, transformation of relationships and effective communications between the physical natural science community, which is represented in this room, and the policy partners, the regulators, the people who need to understand why this data matters to their decision making. And part of that effective communication is effective data transfer, sharing common platforms, but also, as you've just heard from the final talks and everything over the last day and a half, it's a holistic approach. It's not a single topic theme we're looking at here, it's a complex environment. Cities and the rise of the urbanite. It's already been stated that by 2050 we will see, the number of human beings living in urban settings somewhere in the region of 70%. So what are these cities that we're all living in? The largest objects of human creation, they have been described as. They're temporal, they're a co-location of complex services that have led some people to describe them as transaction machines. They're effectively a form of change. Again, you've heard a lot of information in the last day and a half about how things are changing in all sorts of ways. The UK Future Cities team described them as systems within systems. Networks of people, materials, flow of decisions, and effectively, I like this one, a marriage of social and natural sciences. There aren't any social scientists here, I don't think. But I've been to quite a few meetings over the last 9 months where I have been the only physical scientist in the room. I've been the only one who stands up and says, you can't forget about the subsurface in your thinking and planning. So there is still, I think, a major mismatch between the communities, and maybe one of the angles on CUSP going forward is how we start to bridge that gap and make it more effective. But of course, in the McKinsey report, if you've looked at it at all, cities account for a huge amount of the world's consumption. And they are effectively the building blocks of the global community. And therefore, it's not surprising that there's been so much research and a massive expansion of research into urban science. But as again you've heard, it's multi-factor, it's multi-scale, it's looking at, in many other social world, if you like, looking at the living on the surface. It's about the metabolism of cities, the economy of cities, and the infrastructure. And that's where we often come in cities. But as the demands for space and resource are going to increase, never going to stop increasing, then understanding the subsurface is absolutely key. And I would argue it's as important as any economic factor or economic data in a city. So the urban agenda is therefore high on the BGS science strategy, which was released a few months ago. And in my current role as director of BGS Global, I have had the opportunity to travel around various cities and explore some of the applications and research that's going on in these cities. And I'd like to draw on some of that experience and what I'm going to talk about. The growth of cities. This is a diagram from one of our BGS colleagues, Simon Price, which was put together for a volume on the Anthropocene. And the point I want to make is that cities around the globe occur in different geographical settings. They have different geologies beneath the surface. And the cities themselves have got different ages or different stages of development. And if we just look at the UK here, highlighted by the blue and red lines marked UK population and urbanisation, you can see that our cities, this would be typical for many of the post-industrial revolution cities in Europe, saw a massive expansion in our population and urbanisation coincident with the Industrial Revolution. But if we consider cities in, say, a country like South Korea, it's got a population of just over 50 million, which, like Britain, 80% of them are urbanised already. It's got a huge urban population living in a land area that's about 2.5 times smaller than that of the UK. Its cities have developed in the last 50 years, so they're responding and developing in a different way, in a different time frame, to the cities that we know and you've been hearing about over the last few days. And importantly, these modern cities have not been tested by the 1-in-100-year storm. Their resilience hasn't been tested. You can argue ours probably has, and we've also started to think about making efficient use of the subsurface beneath our cities. So there are fundamental differences that I think the experiences from CUSP and other European urban projects can take to the world, particularly places like China, which is undergoing a speed of urbanisation that is almost 100 times the scale and 10 times the speed of the UK urbanisation during the Industrial Revolution. And I was out in India again at the beginning of the year at a workshop where we were informed that India is planning to build a corridor between Delhi and Mumbai, which will have 7 new smart technology cities. It's incredible ambitions. And they're out there, but a lot of them, don't have a thorough understanding of what it is that's beneath their feet and what they will need in terms of resources. This is a beautiful diagram from UK Aid, the Department for International Development report, which was put together by Atkins and UCL London, and it highlights the perfect storm of risks that are facing our cities. And I would encourage you to look at this report. It's called Future Proofing Cities. They look at 129 cities around the world. And that's 5 minutes. Oh my God, I'm only on slide 5. There is no way. So it's an important issue, the work that we're doing here in Glasgow and what it means in how it can be applied around the world. And if you've heard a lot about, or many of the models you've seen of BGS have had a catchment in them, because it's the catchment, the hinterland to the city, that is going to be absolutely crucial for long-term resilience. Going back to the McKinsey report, it estimates that the global demand for municipal water will increase by 40%. of which more than 70% of that will be in Southeast Asia. So everything you've heard this afternoon about watery world is absolutely crucial to the world. And similarly, infrastructure development, new energy demands on new technologies, etc. Therefore, to understand the urban vulnerability, the resilience of our cities, we require this subsurface information. So what are the sorts of questions then a city authority might ask? Some of these you've heard, they're repeating what other people have said. You know, how much is down there? How much? How deep? How do we manage our space? Is the ground stable? What will be the impact of my new metro be? Utility planning and sustainability. A lot of the work that the TNO you heard about is focused on that shallow depth level, which is critical for utilities, and looking at long-term corrosivity. Flooding, we've heard about that. Resources, you know, we can't develop our cities without knowing if we've got enough aggregate and limestone for construction, got enough water to keep the population happy, and energy resources. Another alternative way of looking at this issue is this triangular diagram. It's the staircase, if you like, in a vertical context. And again, it encapsulates for me what the CUSP project's been doing. It's built that platform of data and information. It's started to construct geological models. It's gone into the process and quantitative models and scenario planning. And you've been exposed to all that in the last couple of days. Surveying data in, intelligent solutions out. But they're only intelligent. What's missing off this diagram is what are the questions? What is it that your user of the information really wants to know? And it was very, again, revealing to have the questioning earlier on this today from the lady from Glasgow City Council saying, you know, how does this help me? How do I translate what you're saying into something I can use with my decision making? So Diarmad and I put together a quick list, and I apologize, I hope I haven't left anything out, but again, how do we, you know, the impact of CUSP. It's been on environmental health, sediment, soils and waters. You've heard about geochemical atlases with applications to source to sink from the Lowther streams up in the southern uplands right down out into the outer estuary. You heard something about spatial relationships of soil quality to social deprivation, understanding the movement of fluids and the estuarine record of the Anthropocene. Resilience to climate change. We're at the very early stages of looking at groundwater flow and aquifer recharge under Glasgow, experimenting with such systems. So pioneering a new shallow groundwater monitoring network, 4D predictive models, remediation strategies. Ground stability. The voxelation you saw yesterday and again this morning of the quaternary deposits in particular is going to be crucial for longer term planning and decision making about infrastructure development. So advanced modelling strategies, mixing deterministic stochastic solutions, multiple attributions of key parameters. And finally, energy modelling, underground resources, something Diarmad was very keen and very passionate about. Yeah, we've got those abandoned mines under the city. Let's make something of them. And most importantly, it's about contributing to subsurface planning, developing the common platform, planning guidance. You've heard about GSpec and ASK, I won't repeat. The Atkins report I mentioned earlier, the future proofing of cities, also comes up with a very interesting analysis, and it breaks the typology of cities down into these 5 classes. And it's interesting to adopt this approach, but again, what's missing out of here, there's nothing about the subsurface. And if you look at Glasgow, perhaps as an example of a type 1 city, energy intensive, sprawling, it's an estuary setting on the major river, it's got an industrial subsurface and a sedimentary geology which they've exploited for obviously for the Industrial Revolution. And if you contrast that with, say, somewhere like Singapore, it's an island setting, it's vulnerable, coastal vulnerability, it's maybe a type 4 type setting, it has no natural resources. And it's only now beginning to understand its complex geology, which is not exploited at all. So if I move on to Singapore as an example of where we could go next, Singapore is approximately 4 times the size of Glasgow. And by that I mean the city of Glasgow. And in a recent government paper in Singapore, they're estimating that the population will increase to over 6.5 million by 2030. Combined with infrastructure development, the doubling of the rail network, which will require an extra 5,000 hectares of land, This places huge demands on the surface space. The Singapore government is therefore developing a complementary underground land use master plan. I think one of our Dutch colleagues said, we have to seduce them. Well, I can tell you in Singapore, they're doing it with a vengeance. You don't need to seduce anybody out there. But they desperately need to understand their rock space. And I've already mentioned that. There are 3 tiers of development. Different ministries, different data sets, not talking to each other as you might expect. Typical sort of issues that you find around the world. There's that shallow level of utilities, water, gas pipes, sewage, telecommunications. There's a deeper level of utilizing transport, human space. They're putting offices, shopping malls, university departments underground, even as much as over 50 meters in places. And then there's this deeper rock cavern program they're developing. They want to move all of their surface oil and gas and water storage facilities underground in depths of excess of 200 meters. It's a huge and ambitious place, and it's a wonderful place to start testing and developing what you collectively have learned in CUSP. So what might be the CUSP lessons for Singapore? Their new mass rapid transport system. So yeah, better prediction of the near surface deposits, the stochastic modelling that you've heard about. The rock cavern exploration, they need that bedrock modelling with all those fault analysis that Alison Monahan showed earlier today. Understanding the geological processes and whether those faults are sealing or leaking, whether they're aquifers, what the implication might be of sterilisation of other groundwater resources at depth. But most importantly, and I think I'll come back to this in my final slide, it's about raising awareness of the importance of data systems and the availability and dynamic flow of data between different planning departments, between different research groups, between different regulators. That is something I think that this project has seriously achieved. And just to highlight the global dimension, Diarmad used this slide earlier. There's Glasgow and the CUSP project, hubbed around northern Europe. But it's starting to spread out across other parts of the globe. And at the same time, the BGS urban projects are starting to develop as well in Southeast Asia and the Gulf. There's a clear international dimension to the work and the application of the work you've been doing. And just 2 slides left. Thank you for your patience. Next steps. The project can't finish next month. After all this work, and there's a lot of stuff that still needs to be thought about. It's about integration. So it's the Glasgow Urban Earth Observatory, a platform for multi-use, multi-scale data, developing innovative sensor technologies perhaps, developing the research and user community, exploiting the ASK network that is now set up, and similarly exploiting the GSpec, consistency of data collections and delivery. So finally, my last slide, I just want to reinforce those points. I think this is where Diarmad and I both share the view that this is what this project has really been achieving. It's realised the benefits of transforming partnerships and communications. It's recognised the importance of data availability, the acquisition of data, the reuse of data, data transfer, and also setting city standards. It's discovered how to design workflows, toolboxes for policymakers, developers, and regulators, improve risk management, and nobody's mentioned it, except maybe in passing, but it's really about also the impasse that we've faced for many, many years about unforeseen ground conditions. How do we save costs in development? And of course, there's a holistic approach, the scale of development. And I go back to my point earlier. Moving forward, it's about what is the question or the questions this project and these data that we're working with are going to be used for. Thank you.
Many thanks, Martin. As we're running close to the end of the
I'll be spared any questions.
I think, yes, we'll spare you any questions. If you have any questions, I think Martin's given such a good summing up of the CUSP programme project. I think take these questions away with you as things to think about in the future and starting points for our next discussions. Thank you, Martin.